Today we'll discuss about some other sophisticated equipments used in size separation. One among them is elutration tanks. So this is very important equipment, and generally the principle involved in elutration tank is, any guess, gravitational force. So the process of separation of heavier particles from the lighter ones with the help of vertical directed gas stream or the liquid stream, generally in the upward direction, is known as elutration. So elutration itself suggests that it's the separation of particles, that is heavier and lighter particles, through upward moving stream of liquid or any fluid is called elutration. And generally here in this case, we are not going to use air, but we are going to use the liquid which is moving in upward direction. Let's see the principle. This process is based on the gravitational force. In this method, the movement of fluid takes place in direction opposite to that of the sedimentation movement. So two movements are taking place under here. One is the particles, heavier particles are sedimenting downwards, and the particles who are smaller in size are carried upwards because of upward movement of fluid. So in this way, the red arrow marks what I am showing you on the screen is the movement of lighter particles, and the blue arrow marks what you are seeing is the movement of heavier particles. So heavier particles are moving downwards because of gravitational force, and the lighter particles are moving upwards because of fluid flow. This separation of heavier and lighter particles is generally called as elutration. So that we should remember. Example, here you can see the fluid moves vertically upward while the particles moves in vertically downward direction. If the fluid velocity exceeds, key point is important, fluid velocity exceeds the particle settling velocity, then the settling velocity of particle will not be sufficient enough to overcome the fluid velocity, causing the particles to upward movement. Hence, in this case, separation does not depends on time, rather it depends on velocity of fluid. So, the velocity with which this fluid is moving is very important. You can see the construction, it's so simple. There is a tank with different taps, right, or outlets at different positions, so that we can, Srikar, your cursor is moving here and there. So we can collect the different particles at different heights, and different size the particles can be separated there clearly. Okay. So next is you can see the construction. Construction is so simple and as shown in the figure. Then working in the acceptometer is simple. So it's a size separation technique. Elutration is based on low density of fine particles and high density of coarse particles. It is used for separation of porous and fine particles on non-hydrating inorganic powders. After levitation, elutration tank is filled with dry powders or levigated paste and is mixed with a large amount of water. So simply మనం ఏ పౌడర్ అయితే సపరేట్ చేయదలుచుకున్నామో దాన్ని will make it a slurry, will mix it with the water tank, and we will keep it in elutration tank, and we will force the water to flow in upward direction. Heavier particles, whatever present in the mixture, will fall down because of density, and the lighter particles will be carried with the stream. So that is elutration. Okay, coming to uses, and it is used in separation of insoluble solid particles based on their size, shape, and density. When acid is used to elutration medium, certain fine cosmetic powders can be prepared. So this is the uses, and there are a lot of merits and demerits. You can see the chief demerit of elutration tank is that suspension of solid particles need to be diluted before use. So if there is any hydrophobic substances, water hating substances, then those cannot be used using elutration tank. If there are any sensitive substances to the microbial or these things, so in such kind of substances also you cannot go for elutration tank. So elutration, the major thing is you are going to dilute it with the water, and if your product is sensitive to the water, we cannot go with it. So this is about the size separation. We discussed many equipments and the back filters is one, cyclone separators is one, air separators is one, and now we have seen elutration tanks. So these are the certain basic equipment which we discussed in size separation. So focus in challenge in the principles is important, construction and working is important, merits and demerits of this equipment is important. In last class, I have given some important objective type practice questions, 40 questions. I hope no one has gone through it. అందుకే మీకు టైం దొరకట్లేదు కొంచెం దాని మీద ఫోకస్ చేయాలి ఐ వాంట్ యూ పీపుల్ టు ఫోకస్ ఆన్ దోస్ క్వశ్చన్స్ సో దట్ అట్లీస్ట్ యూ విల్ అండర్స్టాండ్ ఫ్రమ్ విచ్ పార్ట్ ద క్వశ్చన్స్ ఆర్ బీన్ ఆస్క్డ్. So what will be the size reduction, size separation is done. Let's right. So mixing equipment is very, very important. In tablets, where we go for mixing, we to mix all the excipients, right? To get granules, uniform granulation, we are going for mixing in tablets. In capsules also for proper uniform content person, we are going for mixing. In ointments, during preparation of ointments, there are a lot of methods like spatulation technique law, there is a mixing. So to mix, in order to mix ointment bases with the active pharmaceutical ingredients, we are going for mixing. Even in suspension, solutions, emulsions. So all these formulations, we are going to use mixing. That's very, very important parameter, right? So there are a lot of mixings like solid mixings and liquid mixing. You can simply see the difference between solid and liquid mixing. And the solid mixing low flow currents are not possible, whereas liquid mixing low flow currents are responsible for transporting unmixed material. Solid mixing low product consists of two or more easily identifiable phases, whereas in liquid mixing, two homogeneous liquid phase can be observed. So homogenization is possible in liquid mixing. Large sample size is required for solid mixing. Liquid mixing, small sizes is also possible. Solid mixing requires high power. Liquid mixing, low power is also sufficient. So this last point is very important. లిక్విడ్ మిక్సింగ్ లో ఎనర్జీ ఎక్కువ కన్జ్యూమ్ అవుతుందా సాలిడ్ మిక్సింగ్ లో ఎనర్జీ ఎక్కువ కన్జ్యూమ్ అవుతుందా అని అడిగినప్పుడు liquid mixing consumes less energy. So that is very, very important. Next, mechanism of mixing. You have different mechanism of mixing like convective mixing, shear mixing, diffusive mixing. Next, methods లో వెరీ ఇంపార్టెంట్ ఉన్నాయి మనం డీటెయిల్స్ లో వెళ్ళట్లేదండి కన్వెక్టివ్ మిక్సింగ్ లో షియర్ మిక్సింగ్ లో అండ్ డిఫ్యూజివ్ మిక్సింగ్ లో జనరల్ గా కన్వెక్టివ్ మిక్సింగ్ మీన్స్ generally what happens convection type in this type of mixing power inversion with the help of paddles blades screw elements laga mix cheste that is convective mixing aitundi shear mixing means in this type of mixing particles move freely in between the sections of different compositions layer by layer slip avukuntu veltundi diffusion mixing ni micro mixing ani kuda antam so no need of detailedly going into these types just remember types of mixing mechanism of mixing enough convective mixing shear mixing, diffusion mixing. Next, methods of mixing lo we have the important, is important and how many different methods are there for mixing. One is spatulation. You are going to use spatulas for mixing. Trituration, mortar and pestle వాడి triturate చేసి mix చేయడం. Someone like textbook lo sent spatula, or I mean pestle they sent. Yes, it's right. So trituration, mortar and pestle can be used for mixing. Geometric dilution, one of the very, very important concepts of mixing. Sifting, yesterday we discussed about the sifters, or we can say sieves, sieving or sifting. And Manogna said tumbling, so this is also one of the method of mixing. So these are the mechanisms generally involved in mixing. Spatulation, generally we are going to use spatula and simply mix like spoon-like content. Trituration, we will have both size reduction and mixing. So particle size is reduced along with mixing that you can see in trituration. Mortar and pestle, generally glass mortar and pestle are used for potent drugs. And geometric mixing is the important thing you should remember. In geometric mixing, generally what happens is we are going to mix slowly calculated proportions. For example, if you are going to mix 1 mg of API in 10 mg of solvent, you will take 1 mg of API and 1 mg of diluent only. Mix them together, the both will become 2 mg. Now 2 mg of this mixture with 2 mg of the excipient. 2 plus 2, 4 items. Now 4 plus 4, 8 items. Then you'll add the remaining two amount. So geometric mixing law, small proportion. This method is used for the potent substances and mixed with a large amount of diluent. You go for the geometric mixing. The potent drug is placed upon approximate equal volumes of the diluent. చెప్పాను equal volumes తో diluents తో తీసుకొని చేస్తామండి. సో జామెట్రిక్ మిక్సింగ్ లో చాలా కేర్ఫుల్ గా వెళ్ళాలి. So I'm repeating again, for geometric mixing, if for example, if you have to take two contents, 2 mg, you will mix 2 plus 2. So 2 plus 2 means 2 mg of your API and 2 mg of excipient. Then the total will become 4. So 4 plus 4 now. It means now 2 plus 2 became 4. So 4 mg of the mixture plus 4 mg of excipient. Then this content became 8. So 8 plus 8. అలా వెళ్తామండి. So this is geometric mixing. So equal proportions of drug and excipient are mixed, then the proportion is slowly increased. So geometric mixing is very important. Sifting or sieving is also one of the method of mixing. It's very, very important. In this method, the powders are mixed by passing through sifters or sieves. The process results in light, fluffy product and generally not acceptable by many drugs because potent drugs we segregate అయిపోతాయండి. So we don't go for that kind of thing. Okay. Next, liquid mixing is also there. So lot of times we need to mix liquids with liquids like oils mix చేయడం కావచ్చు, oil phases లో aqueous phases mix చేయడం కావచ్చు. So liquid mixing also plays an important role. So there the mechanisms we use or the equipment we use is important. I'll show you these are the things. uh, what is there? No, let me show you that mixers used in liquid. These are blender, cone, double cone, all for solids. Liquid. Propellers. Yeah. So these propellers are used in liquid mixing. You can see this kind of propellers, right? So different positions for different propellers are used generally for liquid mixing. Then we can use turbines for liquid mixing. See, these are the turbines. So bladed turbines, impellers are there, right? Propellers are there. So paddles. These three are the equipments generally used for liquid mixing. ఏమేమి వాడుతున్నామండి? Propellers, turbines, and paddles. You should remember these three. Should please note down. Used in liquid mixing. Then coming to solid mixing, no, we use lot of equipments. We are directly going into the equipments to sort out what different equipments are used. So yeah. Okay, so propellers, turbines, and paddles are used for liquid mixing. Coming to mixing of semi-solids and solids, ఇక్కడ నుండి మనకు equipment start అవుతుందండి. So what different equipments are used? చూడండి, double cone blenders are used, twin shell blenders are used, ribbon blenders are used, sigma blade blenders are used. Planetary mixers are very, very important, used in this pharmaceutical industry. The propellers, turbines, I'm changing the color so that yellow colored all solid mixing లో solid liquid లో అండి. ఈ blue color అంతా liquid mixing లో propellers, turbines, paddles, and especially in emulsions, liquid mixing, silver cell emulsion. These are the different equipments used in mixing. Please note them down. Double cone blender, V cone blender, ribbon blender, sigma blade mixer, planetary mixture, propellers, turbines, paddles, and silver sun homogenizer. So please note down these equipments. Done?
Yes, sir.
Yeah. So starting with double cone blender, these are so simple and so easy equipments. Structure is important and ikkada principle is important. That's it. So double cone blenders produces homogeneous solid mixing of the powder. Equipment involves axial movement. You can clearly see the shape of the blender and see how it is moving. So ఇలా మూవ్ అవుతూ ఉంటుంది. ఇక్కడ you have a cap you to open up. It open చేసి ఇందులో we will fill up the content to be mixed and it will move axially like this to mix the particles. So this blender provides thorough mixing depending on its speed and rotation. Construction is so simple. The body of the double cone blender consists of two cones. పేర్లోనే ఉంది, two
Double
cone
cone.
sections. Yeah. So this upper cone and this is the lower cone. So the rotational axis is perpendicular to the cone axis for and passes through the cylindrical section. So the blender body is held by two lateral supports, one of which support is fitted with the driving shaft. So he's speaking about this lateral support, and this is connected to the driving shaft, and either rotate అయితే ఇదంతా rotate అవుతుంది అంటున్నాడు అంతే. And working is so simple, again same thing. So this is about the double cone blender. The points to be focused here is uses. So where we are going to use double cone blender, what are the merits and what are the demerits? So you can see here, focus clearly. Double cone blender is used in granulation of the dry powders, food industry, chemical industry, pharmaceutical industry, cosmetic industries. ఇక్కడంతా డబుల్ కోన్ ప్రింటర్ వాడతాం for mixing. It is suitable for homogeneous mixing of small amount of powder. This is its